Lesson 1-7, and this is the constant rate of change. So in this lesson we will learn what the constant rate of change is and what rate of change is all about. So for this lesson we go back to the essential question. The essential question is, how can you show that objects are proportional? Okay, so in this lesson we will learn two terms: the rate of change and the constant rate of change. Okay, so let's take a look at this vocabulary startup, and let's see what rate of change is. So rate of change is the rate that describes how one quantity changes in relation to another. Okay, in a linear relationship, the rate of change between two quantities is the same. A linear relationship has a constant rate of change. Okay, so there are two terms that have been uh, defined here. Rate of change, which basically tells us, okay, how one quantity changes in relation to another. So a good example would be probably the average number of words. Probably for myself, I can type probably 60 minutes in 2 minutes. Okay, so every 60 60 words in 2 minutes. So for every 2 minutes I can type 60 words. So in 4 minutes I can type probably around 120 words, something like that. Okay, so that is what we call a rate of change. Now it talks about something else, and we need to define that as well. So when you talk about a linear relationship, okay, what that simply means is that if I am going to graph the relationship between my two quantities into a graph, something like that, okay, if it forms a straight line, okay, that means it will have a constant rate of change. So that's what it's saying here, that in a linear relationship the rate of change between two quantities is the same. So meaning it is a constant rate of change. So if you see a graph here, remember we studied graphs in the previous lessons where this is your x-axis and this is your y-axis. If you see a straight line, okay, that is what we call a linear relationship because it forms a line. Okay, so a linear relationship or a graph with a straight line will have what we call a constant rate of change. So in this lesson, all the examples that we will be uh, discussing will have constant rates of change. Okay, let's take a look at this example, real world link. A computer programmer charges customers per line of code. Okay, so every single time a programmer writes one line of code, there is a charge. Fill in the blanks with the amount of change between the consecutive numbers. So let's analyze this. So from 50 to 100 right here, okay, there is a change of plus 50. From 100 to 150, okay, there's another change of 50. And from 150 to 200, another change of 50. So you can see that the change, okay, for the lines of code will be plus 50 every single time. Let's look at the cost then. So here, for every uh, 50 lines of code written, the cost is $1,000. For every 100 lines of code written, the cost is $2,000. 150 lines written, $3,000. 200 lines written, cost is $4. Now we already looked at the change for the lines of code. It's plus 50 every single time. Let's take a look at the cost this time. So in the cost, okay, so from 1,000 to 2,000, you have a change of $1,000. From 2,000 to 3,000, change of $1,000, and from 4,000, 3,000 to 4,000, another change, same change, which is $1,000. Okay, now you can see when you look at the word constant, okay, constant means same. So you can see right away that the change for the lines of code and the cost are all the same. 50 for lines of code and 1,000 for the cost. Okay, so what it's saying is that for every, okay, for every 50 lines of code written, okay, the cost would be $1,000. Okay, so that's the constant rate of change that we're looking for every 50 codes written, lines of code written, the cost is $1,000. And same thing here, for every 50 lines of code written, the cost is $1,000. Okay, now if we were to label the diagram below with the terms change in lines, so these are the terms that we will be using: change in lines, change in dollars, and constant rate of change. We know that since this is $1,000, this is going to be change in dollars. Okay. And since we have lines here, this will be change in lines. Okay. Now, if we get the unit rate of 1,000 over 50, okay, that means remember what unit rate is, where the denominator should equal 1. So for 50 to be equal to 1, we divide this by 50. So therefore, we need to divide 1,000 by 50 as well. And 1,000 divided by 50 will give you $20. Okay, so the unit rate is $20 per one line of code. Okay, so now we can see, okay, there's only one term remaining, okay, that the constant, okay, rate of change is $20 per line of programming code. So if we get the unit rate of our rate of change, okay, of 1,000 lines, okay, right here, 1,000 lines, sorry, 50 lines per $1,000, okay, if we get the unit rate, and the unit rate is $20 per line, that's what we call the constant rate of change. So again, look at the word unit rate and look at the word constant rate of change, because they are very much related to each other. So if we find the unit rate in a linear relationship, okay, that is our constant rate of change. Okay, let's take a look at example number 1. We can actually use a table to find the constant rate of change. Okay, the table shows the amount of money a booster club makes washing cars for a fundraiser. Use the information to find the constant rate of change in dollars per car. Okay, so if you look at our table closely, we have 5 cars washed. Okay, $40 was the cost for washing the 5 cars. Okay, or the money that they raised, okay, was $40. For 10 cars washed, okay, the money the booster club makes is $80. For for 15 cars, $120, and for 20 cars washed, the booster club makes $160. Now let's take a look at the change on the number of cars. So we know from 5 to 10, you add 5, 10 to 15, you add 5, 15 to 20, add 5. So therefore here, you simply add 5 every single step. Okay? Same thing here. You have 40 to 80, you add 40. 80 to 120, you also add 40. 120 to 160 is also, you also add 40. Okay? So the change for the amount of money the Booster Club makes is $40. Okay? Now if you notice, we already have a constant rate because that's 40 and 5 all the way down. Okay? So, we need to find. Remember, when we want to find the unit rate, okay, we need to make sure that the denominator is equal to 1. Okay, so before we find our unit rate, let's analyze the table that we have, okay, the number and the money. So in what we learned in the past lessons, we can actually designate the number of cars washed as our x-axis, okay, and then the money as our y-axis. So if we do this, we can actually designate the $40, okay, as the change in y, okay. So we can say this is a change in y, because we are looking at the change in the y-axis, and the number of cars washed can be our change in x, because when we look at our x-axis, that's where we can see the change on the x-axis. Okay, so that's a good way of looking at our table, because now when we talk about constant rate of change or rate of change, we can say that the rate of change is actually our change in y over change in x. Okay, so if this is the case, we know that our change in y here, okay, if we look at our table closely, will be 40. So our change in y is 40, and our change in x is 5. So $40 and 5 cars. Okay, this makes it easier for us to find the unit rate. Okay, so knowing that our change in y over change in x is $40 over 5 cars, okay, we can now find, okay, our unit rate, okay, which is change in money, okay, which is our change in y. Remember, our change in y will be our money, so that's change in money, over our change in x will become change in cars. Okay, so that follows to be $40 per car, $40 per 5 cars. The money earned increases by $40 for every 5 cars. Now remember what unit rate again is. We need to make this denominator equal to 1. So therefore we need to divide both the numerator and denominator by 5. So if we divide both of them by 5, okay, divide this by 5, divide this by 5, we end up with this number right here, $8, okay, over 1. So 40 divided by 5 is 8, 5 divided by 5 is 1, which makes our unit rate, okay? So our unit rate here is $8 per car, okay? So what it means is that for every car, okay, the rate of change, the constant rate of change is $8. So the number, okay, of dollars earned increases, okay, by $8 for every car washed. Okay, so that's what the constant rate of change is. Okay, so do the got it problems. You have tables to work with, and let's see if you understand that example. Let's take a look at example number 2. Okay, in example number 2, we are now going to be using a graph. In example 1, we used the table to find the constant rate of change. In example number 2, we will be using a graph. Okay, you can also use a graph to find a constant rate of change and to analyze points on the graph. Okay, so the graph represents the distance traveled while driving on a highway. Find the constant rate of change. So we discussed what a coordinate system is, and this is quadrant 1 of our coordinate system. So it doesn't show the other 3 quadrants because when you talk about time and distance, it's both of them are positive, so we don't need to show the other 3 quadrants. Okay, there's no such thing as negative time nor negative distance. So let's analyze our graph. Okay, so on our y-axis will be the distance traveled. On our x-axis will be the time it takes them to travel that distance. Okay, so this is a straight line, meaning this is a linear relationship. And according to what we learned at the beginning of the lesson, okay, when you talk about a linear relationship, it will have a constant rate of change. So if it has a straight line such as this one, it will have what we call a constant rate of change. Okay, now look at the points that were graphed here: 0, 0, 160, 2, 120, and 3, 180. Okay, and if you notice again, these are called ordered pairs. Okay, the reason why they're called ordered pairs, because every ordered pair has x and y. You read x first before you read the y coordinates. Okay, so the x coordinate and the y coordinate. Okay, so to be able to find the rate of change, we need to pick, okay, 2 points on the line. And in this example, the 2 points that were picked were 0, 0 and 160. So these are the 2 points that were picked. This point right here and this point right there. Okay. Now we need to find the change in y. Remember in example 1, okay, we talked about, okay, our rate of change. Let me rewrite that. Rate of change is the same as the change. Okay, sorry, that's the wrong spelling. Change in y over our change in x. Okay, that's how we find the rate of change. So if you look at these 2 points, 0, 0, okay, and 160, let's take a look at the change in y. So the change in y, sorry, our change in y right here, okay, you look at 60 and you look at 0. So we subtract 60 minus 0 because that is the difference between the two. That is the change in y, okay? And our change in x, okay, would be 1 and 0. So we do 1 minus 0. Okay, so doing that, we have this, okay, given here, right here. So change in miles, okay, because that is our y-axis, miles. This is our y-axis. And change in hours, which is our x-axis. This is our change in y over change in x, which is the same as, okay, 60 minus 0, okay, which is our change in miles, over our change in hours, which is also our change in x, okay. If you do that, we end up with 60 miles per hour. And if you notice, this is already the unit rate, okay. So the constant rate of change is 60 miles per hour. Okay? So an extension of example number 2 is example number 3. So explain what points 0, 0, and 160 represent. So you notice, okay, this is not only a graph. All these numbers mean something. Okay? Now, for you to understand the meaning of those numbers, you need to look at, again, the axes. Okay? On the x-axis, for example, okay, you know that it's all about distance. Okay? On the y-axis, it's all about time. Okay? So when you talk about the first 0 here, for example, that talks about 0 time. And this 0 represents 0 distance. Okay? This 1 represents 1 hour. And this 60 represents 60 miles. So let's take a look at this example 3 and let's see what 0, 0 and 160 represent. So in this case, the point 0, 0 represents traveling 0 miles in 0 hours. Okay, the point 160 represents traveling 60 miles in 1 hour. Notice that this is a constant rate of change. So this one now becomes our constant rate of change, 60 miles in 1 hour. Okay, because if we make this into a rate, this transforms in 60 miles per 1 hour, which is also our unit rate, which is also our constant rate of change. Okay? All right, do the got it problem and see if you understand this example. Finally, let's move on to example number 4. And example number 4, okay, the table and graph below show the hourly charge to rent a bicycle at 2 different stores. Which store charges more per bicycle? Explain. Okay, so in this example, we have a table and a graph. Remember, we can find the constant rate of change when we use a table. We can also find it by using a graph. Okay, so we have pedals rentals. Okay, and you have time and the cost. So in pedals rentals, for every 2 hours, okay, the cost is $24. For 3 hours, $36. 4 hours, $48. Now, if you look at the change in the cost, it's plus 12 every single time for the cost. For the time, it's always adding 1. Okay, now we know that the rate of change is going to be, for pedals rentals, rate of change is, we get this 12, which is our y, this is our x. Again, change in y, which is 12, over change in x, which is time, which is 1. Okay. Now, if you notice, the denominator is already 1. So this is already our unit rate. So since this is already our unit rate, this is also our constant rate of change. So our constant rate of change for pedal rentals will be $12 for every hour. Okay, let's take a look at super cycles. In super cycles, okay, again, we now look at our y and our x. Okay, so again, we look at the change in y over the change in x. Change in y will be from 16 or 8 to 16, okay, which is going to be 8. So change in y will be 8, okay, and our change in x will be from 1 to 2, which is 1. So this is 1 and this is 8. Okay, so this will be $8 per hour. Okay, So again, our denominator is equal to 1. Therefore, this is also our constant rate of change. Now we compare $8 and $12. Obviously, $12 is more expensive, okay, than $8 per hour. Okay, so we can actually now conclude that the cost at pedal rentals increases by $12 every hour. The cost of Supercycle increases by $8 every hour. Therefore, pedal rentals charges more per hour to rent a bicycle. Okay, and this is the end of our lesson. Thanks so much for watching.